Onions. We love to hate them, or rather, our eyes hate that we love them so much. They're one of the oldest recorded vegetables in continuous use, with records dating back 4,000 years, and they've made their way into pretty much every culinary tradition in the world. As amazing as they are, they've got one really annoying flaw: all of the crying. Every time you cut into one, you can't help but well up like you're watching a sad dog movie. We actually know quite a lot about what's happening at the chemical and biological levels to make this reaction happen. But a study published in October of 2025 looks at the onion crying problem from a new perspective: physics. They examined the droplets flung out of an onion being cut in various ways with a precisely tuned onion guillotine. And the results show us there is still more to learn about how onions make us cry. Now, before we dive into the French Revolution of onions, let's recap the science behind the onion's uncanny ability to bring tears to even the toughest eyes. There's a chemical that gets released when you cut into an onion called syn-propanethiol S-oxide, which causes the glands in your eye that produce tears to work overtime to attempt to flush the irritant out of your eyes. The weird thing is, onions don't contain any propanethiol S-oxide. Instead, they contain the ingredients for it. First, when you cut into the onion, your knife breaks open a lot of cell walls. And this is all the onion needs to introduce the enzyme alliinase to the air and produce 1-propene-sulfenic acid. That chemical then reacts further with another enzyme to make the tear-inducing propanethiol S-oxide. Given how long we've been tearing up at onions, you might be surprised at how recent some of this science is. We only discovered that second step, where 1-propene-sulfenic acid reacts to another enzyme to make the actual tearjerker substance, in 2002, which to me is like 5 years ago. So that's the chemistry behind the effect. A weird side note: onions get their sulfur from the soil, and acid rain contains a lot of sulfur. So a strange consequence of the success of tackling acid rain in many urban areas is that it might actually make onions milder. It feels like it was worse when I was a kid. Maybe I'm just stronger now. This molecule is also pretty much unstoppable once it gets into your eyes, so the only way to truly avoid tearing up is to prevent it from reaching your eyes in the first place. So the chemistry and biology are pretty much solved, but what hasn't been addressed yet is the physics, as in we don't know exactly how this substance travels to your eyes in order to be able to stop it. Enter the onion guillotine, courtesy of a research group at Cornell University. They also employed high-speed cameras and an electron microscope to test which configurations of knife sharpness, angle and speed of cutting, and temperature of onion resulted in the worst onion juice splashes. They found that the chemical is carried in droplets, released in an initial burst when a blade first punctures the onion's surface, then more slowly as the blade travels through. In their tests, a more blunt blade applied more pressure to the membrane before breaking it, causing a bigger burst of droplets. And that reinforces the wisdom that you should always use a sharp knife in the kitchen. Keeping blades sharp also reduces the chance of injuring yourself, which seems a little counterintuitive, but it reduces the amount of pressure you need and the chance of the knife slipping. But this is another brand new reason. The Cornell team also found that cutting faster caused more droplets to be released, so a cautious approach with a sharp knife might be the best way to minimize tear production. As for the common hack of putting your onions in the fridge to somehow limit their ability to hurt your tear duct's feelings, the researchers did not find any support for this. In fact, chilled onions released more droplets in their experiments. They thought that this might be because the onion tissues get stiffer when cold, causing them to absorb more of the knife's pressure before breaking, then bursting with even more energy. There's another solution running around out there, which is that you should put a damp towel or bowl of water near where you're cutting. Given that the offending chemical is water-soluble, if you could somehow get the onion droplets to hit the water before it hits your eyes, that seems like it could work. It wasn't part of the experiments in this paper, but if I'm allowed to make requests, it might make for a good follow-up. Our speculation, though, is that the Cornell team's experiments show the droplets flying upwards, so water on the worktop can only work to mop up splashes and bounces, and wouldn't be in a position to stop that first attack on your eyeballs. Outside of just stopping a common kitchen annoyance, this research has implications for food safety in general. Droplets sprayed from vegetables don't only carry tear-inducing chemicals, but also potentially foodborne pathogens as well. So this research suggests that a sharper knife keeps your kitchen safe in yet another way by preventing potential pathogens from being spread around. Armed with the knowledge from an onion guillotine and some fancy imaging equipment, we can at least help you out if you really can't stand that stinging feeling in your eyes. The best way to limit the amount of onion droplets spraying into your eyes seems to be to keep your knife sharp and to cut slowly, short of investing in goggles anyway, which I have heard from prep cooks is something they do. And wildly, that strategy might also keep your whole kitchen safer at the same time.